I'm just gonna review some resources that I have here. Basically the same ones that I was reviewing last time that I streamed. I'm going to do, I think, network info first and try to go fast over them. I'll probably start with these ones here. I'm not gonna talk much probably. So to understand the internet communication is very complicated because there's multiple different parts. And it's hard to find resources that talk about all of them at the same time. So as far as I understand now, there's basically the NIC, which is the hardware card that actually connects to the motherboard. And the way that the communication happens is through the buses and the ports. So the ports is kind of like the entry point to the hardware piece, to the PCI, peripheral components. I think it's interface or something like that. So basically all these components are connected through these buses, and then there are standards to determine how they're going to communicate with each other. So basically protocols. And that's what the USB is the Universe Serial Bus. It's just a protocol to connect the devices. So the NIC is a specialized hardware card. As far as I understand, the way that I have, the one that I have here, and I think that most people have, is not open source, the code. So there's both code on the hardware itself, obviously, and then there's code from the driver, which is the software that is built for the NIC. And for this NIC that I'm using, and I think for most NICs it's probably the same one, it's not open source, so you can't really look into the code. And I haven't spent too much time, but obviously you have on the Linux side, you do have open source code for the drivers, but I haven't spent too much time looking into it yet. I'm gonna watch a bunch of videos about NIC cards. So the NIC has some logic to check if the frame is correct, and the NIC is going to interface with the driver is going to be the bridge between the NIC and the operational system. The confusing thing is that, like, in order to think about this, is that on the hardware level, the only thing that is running is actually the operational system, and then the operational system gives the CPU to the process. So, and it synchronizes everything based on clock cycles. So based on time, the scheduled time of the CPU. So the way to think about it is that on the actual hardware, there's gonna be like a synchronization between the operational system and the driver code, but they're basically using the same physical space to deal with the information that is coming in. So it comes from the cables and is parsed through the NIC that does the check of redundancy, which is a circuit on the actual hardware that works kind of like a loop with an XOR gate. That is going to basically check the sum of the bits to see if they are 0, I think. Or it's going to check if the sum is equal to the standard side, basically. There's two different types of checks. One is this cyclic redundancy check, and the other one is the checksum. And they both check something related to the sum of the bytes of the whole message, but I think they're slightly different. And the checksum is on the software, and the CRC, cyclic redundancy check, I think, is on the hardware. And it's going to be basically a loop circuit that has some XOR gates. And it does basically shifting and XOR on the bits of the message to check if the frame is valid. And then if the frame is valid, then the driver is gonna parse that. And then that's the part that gets complicated and confusing, because you also are gonna have the operating system layer that is gonna have firewall basically to filter the messages. Yeah, but the mental model that I have now is that the driver is gonna parse from the NIC, and then it's gonna create a bridge with the operating system, which is gonna ultimately send the bits at some level of the message to the process that is actually receiving them. Is gonna do whatever the process does to make sense of the information, the data that is coming in. But the firewall process, the firewall parts and the proxy parts are kind of confusing. So that's what I was trying to clarify. I'm still trying to clarify now. And because there's so many layers, it gets confusing to like parse through everything. I am reading a book now for this, the Understanding Linux Network Internals, but I already forgot. Maybe I should look into the images. I think I took some images from this book. I think I should probably go over the images that I took from this book, because he has some very nice flowcharts, but I don't remember if I took like a lot of pictures or just a few. This book here. I basically ran out of tokens or of words that I can use. I'm just waiting to get back so I can boost the speed again. Maybe I put it in a different place. There's so many. I don't remember if I put it on hardware. Maybe OS. I think I put it on that OS. Yeah, here. Yeah, so I'm gonna look into these ones after. Because on that, this book is very good. This Understanding Linux Kernel is one of the best that I found. The Linux books are the best because obviously it's open source, so they talk about like the whole process. It's kind of hard to like remember all the details and everything. But also, like, I think I make it's kind of confusing because of the. It's hard to think about the hardware itself, like the bridge between the hardware and the software. Because if you think physically, everything is happening on the same logic gates. So I think that's the part that's kind of confusing. But it's probably simpler. It's just going to be codes from the process that creates the message, the communication protocol. It's usually going to be TCP/IP, so it's going to be acknowledgement and I forgot what it stands for. But it's basically like the first messages should see if the receiver and the sender, like, synchronize the receiver and the sender, and then it's gonna pass like the frames, sender frames, and trade data back and forth. The process is gonna be the thing that ultimately is gonna make sense of the data. Yeah, so I think that's how it works. Like the layers of the OSI model starts with the process, then it sends to the OS. Then the OS sends to the driver sends to the NIC, the NIC sends to the wire, and yeah, back and forth like that. But there's also this thing about multiplexing. The multiplexing is basically a logic gate that allows you to put multiple different cables on the same thing. Like it connects multiple different ports to the same system. So it allows you to use only one cable to send data from multiple different places. That's basically what they do to save space. And the way that this is another thing that it has nuance because depends on the way there's different protocols to parse the signal. So like to encode and decode, to have a demultiplex and multiplex, I think, on both sides, and one basically receives one signal and like distributes that through like multiple parts, and the other does the opposite basically. So you only use one cable between. But then like one of the strategies, the strategy that I remember is to like you send one bit at a time, and then on the other side it figures out by the timing of the signal. This is another thing that is complicated because of the clock cycle. So you also have to regenerate. You have to basically synchronize the clock cycles between the computers, because obviously they're going to be different. But now I forgot the name. There's a name of an algorithm. Like there's multiple different algorithms that do that, obviously. But I think the one that I remember, I don't remember the name, but I remember that it basically kind of like merges the signal of the data with the signal of the clock, and it uses, I think, fast Fourier transform to combine the signals into one signal. So that's the encoding, and then on the other side does the other process to reconstruct the clock cycle. Last time I think I talked about this, and there's a video, and I forgot the video again. But I forgot the exact circuit that he uses. But I remember it's a loop, and I think there's a phase shift on the loop, and then based on the period of the phase shift, it figures out what the clock cycle was. Like it puts the signal at the. It allows you to determine at what moment the signal is gonna be considered as 1 or 0 based on the data. It's based on the transitions from 0 to 1. That determines what a signal means. But this is more for decoding the message. Decoding and encoding. is also from a video. This is basically what I was saying. Application, then I think the kernel and the driver communicate with the NIC. And the way that the NIC is gonna work is gonna be based on like a circular queue. So you always have a request coming in, then they put on the queue until the queue reaches the maximum size. And if a request comes in and the queue is full, then it just discards the package, I think. Then what happens is that based on the protocols, they are based on timing. So if it took a certain amount of time and the client didn't receive a response from the server, it's just going to send another signal. So obviously it's going to depend on what kind of protocol it is. Yeah, so there's also this other thing about the operational system, which is dynamic host. It's DHCP, but I forgot exactly what's the. Let me look for. It basically sets up the computer automatically to find the DNS server and to set up the routing table as well, like the cache of the information of how the computer is going to connect to other devices. I think it's DHCP, but Dynamic Host Control Protocol, something like that. Yeah, the Dynamic Host Configuration Protocol. So the OS has these things. So like on the conceptual level, what happens is that the OS is gonna set up all the settings for the configuration. So it automatically finds the DNS server. It sets up the IP address, the routing table, and the proxies and the firewall. The firewall is gonna be basically a filter based on patterns of the frames. So, but yeah, maybe actually this is this distinction that is not very clear because it could be the driver as well. But I think for finding the dynamic host protocol, configuration protocol is probably the operating system that does that. But I'm not really sure. I think I'm gonna ask ChatGPT and Gemini about this. Yeah, Bootstrap protocol. So I think that is done by the operating system. This is another thing that is kind of not really like this. This one is not very hard to understand, but it is kind of like I don't think many people talk about. But it's basically you're gonna have I don't remember exactly how it works, but it's based on certificates and authority nodes on the network that determine what is a valid website. So the DNS, the name service, is gonna translate the IP, translate the URL into an IP, and it works based on this peer-to-peer authority system, which opens for vulnerabilities as well. There was an attack some time ago that you use this, so you hijack a bunch of computers and then you send like a fake authority, or like you create a fake system or a fake nodes that's hijack the authority nodes, and then you basically like do the wrong translation. So you translate the DNS to a wrong IP address, and then allows you to hack stuff. But then this was solved some time ago. But then recently the NSA was talking about this again. I think I'm gonna ask LLMs what is the distinction of responsibility. What was the name for the? There's like a protocol for synchronize the clock. Fucking data recovery. Yeah, fonts. It's basically this video here. It shows circuits. Also, there is a delay. SPI filter is the name of the thing. NCO. So based on the delay, you adjust the phase here, and then you're able to decode like that. But it's still kind of confusing to me how it works. Like the confusing part is just the annoying details about the nuance of what is going to be considered a 1 or a 0 on the message. And it's very like it's kind of difficult to think. It's like abstract to think about because like when it comes to the physical thing, because obviously it's very weird. You're just sending like frequency of information across the wire, and then based on the frequency, you can decode the information. It's pretty crazy. It's like there's all these systems and layers involved. It's pretty mind blowing that the message still gets to the correct place. Yeah, this is the cyclically redundancy check. I forgot what is the difference, so maybe I'll ask LLM as well. Difference between this check and the checksum. The checksum, I do remember that you basically sum all the bytes of the message, and then on the other side you sum as well. And if it's different, or if it's not 0 or something like that, then the message is wrong because someone changed the number of bytes or like the sequence of bits. But it's not very reliable, just like a because you can change the bits and still have the correct message, so that's why you have these additional checks. Yeah, so I think that the driver just makes sure that is a valid frame that you are receiving based on these circuits that are actually built in on the hardware and additional algorithms that are built on the software, which is the driver, that's going to determine whether or not the frame is correct. And probably is going to have the algorithms for the queue stuff. And for the control policy or quality service of the thing, because obviously if you have multiple different requests coming at the same time and have a queue, there needs to be a way to prioritize or to check which requests have higher priority. So I think that's what the driver does. Then once it does that, then the OS takes over to filter the requests, and then after the OS filters, then it sends to the process. And it's all the thing that is kind of trippy, but it makes sense. Is that the data is gonna be directly put on your hardware. So like after it goes to the OS, it goes directly in the memory, I think, of your hardware. So, but that's the reason why it's possible to have all these attacks, because you have to interact with the external system in some way. Or maybe a better question is how the OS checks if a process needs the packet. That's also confusing. I guess like the process is gonna do the request in the first place. It's gonna be based on the frame. That's like the way the OS parses the frame is gonna determine. I still like have to clarify the nuances. This one there as well. So the communication, this is another tricky part, but it's kind of simple. On the concept is simple, but the nuances are kind of hard to because there's several different strategies like everything else. But the principle is basically you have the bus which is going to connect everything, and then have different systems that are going to use the bus to send data back and forth. And each system is going to have multiple different ports. And the protocol to determine how the systems are going to communicate is going to be the I/O protocol, so input output, and there's going to be different strategies to determine when each component can send data on the bus. And there's also, on top of that, there is the different strategies for interrupts on the OS level. So the OS is basically switching between processes, and it does that based on the scheduler, which has a timer. And you're gonna have all these different systems trying to gain the OS attention, pretty much. And the way that they're gonna do that is by triggering or by calling a low-level function on assembly, which is basically directly on the hardware. But I think like it's both on assembly and the hardware have interrupts. But for this I/O, it's probably gonna be done at the software level. So like the basic strategy is gonna be polling, which means that the process is always triggering, trying to get the OS attention. So sending a signal to the OS to get data from the device. But that's not very good, obviously, because then you're wasting a bunch of computation, you waste a bunch of clock cycles, like always sending the signal. I think the other strategy is to like send the instruction and then go into a queue. And then when the OS has time, it checks the table of the interrupt requests and determines which one has higher priority based on the quality of service. And then based on which one is going to use the reorder buffer, or it's going to, not sure if it flushes, but it's basically going to take the stack, the registers that are currently on the CPU, so like the states of execution of the CPU, and it's going to save them on memory, and then it's going to handle the request, and then later it's going to go back to the process that is stopped before. The best way to think about the mux is like a highway where I have multiple different lanes, and then they converge towards a point. And the traffic light that determines which signal goes is the decoder of the mux. So that's basically what is happening. On both sides, like you have one highway that connects both buildings, and then inside of the building you have multiple different lanes. And the strategy to synchronize the encoding and decoding is gonna be like what determines what card goes first into the only lane that exists. And realistically, most systems nowadays have two different lanes. One to send data and another to receive. That's called duplex. Before they only had one lane, so you had conflict. Like one thing was trying to send data, the other one's trying to receive, then you have a conflict, and then they send a message to the network, sending that telling everyone that there was a conflict, so that the processes waited some random time, and then try to send the signal back and forth again. But nowadays it's mostly duplex, so you escape of sending and receiving data because it's actually two different lanes. One lane is only one orientation, the other one is the other orientation. And they get synchronized by the mux and demux. I think that there's several different strategies. I think one strategy is like to use fast Fourier transform to collapse all the waves into one. That's basically what fast Fourier transform does. And then on the other side, we decode, and it's based on polynomial multiplication. And the other strategy is gonna be like to cycle the time, I think, between them. There's gonna be the difference between time and space, obviously. So I think that the variance of strategies is gonna be like somewhere along the gradient of time and space. Either you're gonna do something with the space, or you're gonna do something with the time. And this is just standards of the subnets, because obviously your system can have multiple different devices on the same network. They have used subnet to differentiate them in the local network, and then on the external network, you use only one IP, I think. And these like are the standards of how you set this up. Sure. So this is the state machine of the TCP protocol. I forgot what this SYN stands for. ACK is obviously acknowledgement, but I don't remember what this SYN is. I do remember that the first signal that the computer is gonna send is the broadcast, which basically like shouting to the whole network the IP address you want, and then after you find that IP address, it creates the bridge, because all the devices along the network, they cache the state based on hash maps. Virtual internet for. So this, I don't remember where I saw this, but I think also as it was on this Thomas Zaman YouTube channel. And I think this is related to synchronization. I think this was from the Chromium, yeah, anatomy of web requests on the Chromium documentation, I think. That the user URL sends resolves the DNS, sends the IP address, and TCP sync. I think synchronization, probably. Then acknowledgements, handshake, TLS handshake for the encryption. Get process requests, return data, parse HTML requests. And then obviously, there's another thing that I think on the beginning I didn't understand this, but it makes obvious sense, like it's common sense when you look back at it, but like there is no information about the GPU and stuff like that being sent. It's just strings, I think. Strings, which is gonna be bytes of UTF-8 probably across the wire, and then the process is gonna rebuild everything. So it's gonna parse the string. So when you think about it, like a browser is a state machine that parses the strings and does draw calls to the GPU to change the state of what the screen shows based on this parsing process. And based on this, is kind of confused because now I'm not really sure. It's saying here paint instructions, but I'm pretty sure like it only makes sense that obviously